how do you get started with it? Wouldn't you pick the largest bill value that is still less than or equal to this amount first?
Yes.
Yeah.
Okay, very good. So let me just write that down. Pick the largest bill value that is less than or equal to the amount. In this case, what would that be?
32.
32, very good. So we now have 132 bill, okay? And then subtract 32 from the amount and handle the rest. Similarly, okay. So after 32 is subtracted, how much do we have? We have $5 and 5.375 left, right? So we do the same thing. Pick the largest bill value that is less than or equal to, but this time it is $5 and 37 cents or so. So what would that be?
$4.
$4 bills. Okay. So that means we have to subtract $4. Oh, okay. Oh my bad. Okay. So after that, we subtract that from that amount. I can write a program to do this faster than I can actually illustrate it in an example. Okay. So now we have $1 and 37.5 cents to deal with, right? And then we do the same thing. What would be the next item to pick? A dollar bill. Okay. And we are left with 0.375 as a fractional value. And then what do we pick next?
A quarter.
A quarter. Very good. Okay. So this time we pick a quarter, and then we have 0.125 left. So we pick a 0.125, and that concludes the whole thing. Okay. Now I know it is awkward, but if I give you enough time, can you do it?
Yes.
Yeah, it's all about just comparing. There's no division. Now, with our existing currency system, there is division involved, right? Because if you have to make a change for, say, 97 cents, you have to pick out 3 quarters. But how do you know it's not 1 quarter or 2 quarters or 3? You have to have 3 quarters. You have to use division. Okay, you pick out the quotient from that division, and then that tells you how many quarters you need. In this case, we don't need division. It is all about just comparison. You look at the amount that you have to deal with. You look at the currency choices. You pick the largest one that is less than or equal to the amount you want to specify, and then you're done. You're done with that currency part. Okay? So can we do this? Yep. Okay. So now the next question is, how does this relate to binary numbers? I mean, this doesn't seem to be related to binary numbers at all. Well, let's go ahead and take a look. Okay, we have 1/8 here, and we have up to 32 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 entries here. So what I would do is to put in a table. And let's see, table tool is over here. Okay, so we'll have, well, let's say 2 rows and 9 columns. Because I'm using a bigger font, it does not display everything as it should. Okay, so now we have a table. What I'm going to put in the table is to indicate how many $32 bills do I need, how many $16 bills do I need, how many $8 bills do I need, 4, 2, 1, and I would even go to the fractional side, which is not even mentioned in the book. The fractional side is no different from the whole number side. You're just going into fractions instead of having whole numbers. We deal with fractional numbers all day long, especially if you are a carpenter. When you specify a drill size, a bolt size, or anything like that, you say, oh, I need a wrench, and it has to be, the 5/32. Okay, and or 64th. You specify in all those fractional units, and if you look at the base of those fractional units, they're all powers of 2 already. So we are actually already using a system like that. We just do not know, or we are not aware that we are dealing with binary numbers already. So now we have this system here. If I go back and look at the amount I have to specify, I know I need one of this. I know I need one of this, 0 of this. We know we have one of this, 0 of this. We have, I think, one of these, 0, 0, and 1. Do we have a binary number?
Yeah.
Yeah, we do. Okay. So basically we can say in binary land, the dollar amount is 100,101.011 in base 2. We have just converted a quantity, which is $37.37.5, which is an amount. Remember, it was an amount that was originally specified or represented as a decimal number. We have just converted that decimal representation into a binary representation. Not only did we convert the integer side, we also converted the fractional side. Are you guys starting to see the conversion process? Is it difficult? Is it mysterious? It's just a way,
Just tedious.
It is tedious, but when you write an algorithm to do it, then the tedium goes away. Okay. So the next question is, if I give you a dollar amount from binary land as a binary number, can you figure out how much money we are actually talking about?
Yes.
Probably, right? I mean, all this is doing is to specify, how much of $1 bills do we need, how much of $2 bills, $4 bills, $8 bills, $16 bills, and so on. How much of each one do I need to specify the quantity? That's all there is to it. Okay? So are we comfortable with binary numbers? Yes? If you can work in a supermarket and make change using our existing currency system, then you know how to deal with this already. This is so much better than the existing currency system because it is completely regular. Okay? Any questions? Well, let's go ahead and do one exercise, okay, to go the other way around. Okay? So how much money is, let's pick, 1011. I'll pick something easy, okay? 0.11, okay, in base 2. Okay, so we want to figure out how much money we are talking about there. So the quickest way to do it is to use a table. So what I will do is I'll use exactly the same table, but this time I will use it to go the other way around because we are starting with a binary number specifying how many of each type of bill we have. So once again, we start with the smallest one is an eighth of a dollar. Then we have a quarter of a dollar. We have a half of a dollar. 1, 2, 4, 8, 16, and 32. Now it is important to remember why I picked these specific numbers. One has to be there. The unit has to be there. On one side we have power. We have fractions of the power of the base we're dealing with. Since we're dealing with base 2, this means the fractions have to be 1 divided by 2, 1 divided by 4, 1 divided by 8, and so on. On the other side, we have just powers of that base. Since we have a base 2 system, so it is 2 to the power of 0. 1 is actually any number to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8, and so on. Okay, so we have basically just powers of 2, because guess what? 0.5 is also a power of 2. What is the power? -1. Okay, and 0.25 is also a power of 2. The power is -2, -3, and so on. Are you guys starting to see a pattern here? Where all these columns, each one represents a power of 2. Okay, all right. So now we look at this number here, and then we start with the unit. Okay, we have $1 bill, one $2 bill, 0 $4 bills, one $8 bills, and since I do not specify 16 or 32, by default they are basically zeros. On the other side, I have one $half bill, $half coin. I have one $quarter coin, and I have 0 $8 coin because if I don't specify anything to the right hand side, they're basically implied to be 0, which is the same way we represent numbers in decimal. Okay. Now, can we finish this conversion? Can someone tell me how much exactly? Go ahead.
1175.
1175. Very good. So it is 8 plus 4. It's 8 plus 0 plus 2 plus 1 plus 0.5 plus a quarter. So that adds up to $11.75. Okay? Are we okay now? Because we have just done it in both ways. Okay? We converted it from the base 10 representation to the binary representation, and now we go from binary back into base 10. Okay? But it is important to remember, I have to re-emphasize this again, the quantity is still the same. Okay? The quantity represented in base 2 and the quantity represented in base 10, they're all representing the same quantity, the same amount of worth. Okay, you can buy the same amount of rice or flour or gasoline with this much money. It is just a different way of saying how much money we are talking about. If you will, you can actually look at it as, one is euro, one is pound, and one is US dollar. Okay, just different units of measuring something. Okay, or if you want more extreme cases, you can put yen or is it peso? With they have this huge amount. Okay, but you can specify the same amount of money using different types of currencies, and it's the same thing here. Okay, are we good so far? Okay, so this is a little digression before we can go back and talk about networking, because the first thing we have to talk about with regard to TCP/IP, which is the main protocol that we use for networking, because why is TCP/IP important? There are tons of other types of networking protocols like NetBEUI and so on and so forth, but what makes TCP/IP stand out and make it more important than the other protocols? If I want to talk to another computer on the other side of the world, what protocol do I need?
You use IP because it's compatible.
Because it is the most commonly used language. Okay? It doesn't mean TCP/IP is the best networking protocol. It does not mean it is the most efficient networking protocol. It simply means it is the one that is most spoken by most computers. Okay? It is, basically a universal language for computers in terms of networking. Now, you can definitely try to invent your own language, in terms of networking that is more efficient, more secure, and also easier to handle than TCP/IP. But guess what? You will be the only one speaking that language. Okay, if you want to talk to another, computer, the other computer has to install special software just to talk to you. And that computer has to connect to your computer physically. If it is halfway around the world, there's no way your transmission can reach the other side, because guess what? Every computer along the way can only understand TCP/IP. So that's why TCP/IP is so important. It is the most recognized networking language, so to speak. Basically, a protocol is a language. Okay, it's a language specification. It tells another computer how to interpret the zeros and ones so that it becomes a file, an image, a transmission of some kind again. Okay, so we are getting back to TCP/IP now. TCP/IP, and we'll go ahead and change the style back to heading 1, and we'll get started with it. With TCP/IP, the first thing you have to remember is, what is a LAN? What is a local area